The SKNode class is the basic building block for most of these SpriteKit elements. For the rest of this video, whenever I say nodes, I'm referring to SKNodes and their corresponding subclasses. Nodes are organized in a tree-like structure, and we call them parents and children. You can basically imagine that a child node is kind of like a subview of the parent node. Usually, at the top of our hierarchy, there's a scene node with the class SKScene. All other elements are children of this node. The scene node will then execute the update loop that we talked about earlier, and thereby it influences all of the other nodes, which are its children. Every node in this hierarchy has its own coordinate system, which it passes onto its children, which are then positioned in said coordinate system. If this sounds a bit complicated or confusing, don't worry, it will all make sense once we apply the logic in the actual game. But it is really helpful to know these kind of things. Nodes are positioned by using the position property, which is a point that consists of x values and y values of the corresponding coordinate system. We can also use x scale and y scale to scale the node, and z rotate to rotate it. If we change one of these properties, it will automatically affect all of the children of the node, which will make the same exact change. SKNodes themselves cannot draw any visual content, but since many of their subclasses do just that, there are a few properties and methods that we should understand. Frame is what we call the square that surrounds our node. This property is used when the node is drawing visual content, and each node subclass determines the size of this content differently. You can do this either explicitly, for example, when you have an image and a SKSprite node, or you can do it implicitly, for example, when you have text with a SKLabel node, where the size of the frame is dependent on the text and its font size. We can use the getAccumulated_frame method to get a square that surrounds additionally to the frame of its own node. All of the children's frames as well. Because even in the coordinate system of the parent node, they don't necessarily have to be inside of the frame. Other properties, like the alpha value or is hidden, affect the appearance of the nodes and their children. And I think those two explain themselves. Even though SKNodes themselves are not able to draw anything visually, they are very, very useful elements for our SpriteKit projects. Let's have a look at a few examples. We can group multiple visual elements in a container that doesn't have to be visually represented. For example, multiple buttons grouped within a node, which allows us to access them more easily. A common practice for using SKNodes is the so-called layering of content, where we create multiple layers, such as background, world, or head-up display, which all get a SKNode as parent to allow us to separate them within our scene. Now let's have a look at the structure of such a scene and how we can add children to it.